Good evening, class. I'm Daniel Mutia, and I'll be taking you in Engineering Survey 1. In this Engineering Survey 1, we are going to go through several topics, but for today, I would like to start with leveling. And this is all about road construction. It's also involved in buildings, setting out. You need to know the levels. You also need to know the levels of a road in order to ascertain the pavement and also to know the gradient, and also it will assist us to have a level service in the road service. It will also consist uh, different heighting methods of determining elevations. It will also consist, we will also go through, know what is datum, what is reduced level. I'm going to share my screen so that you can be able to see what I'm going to present to you. Okay, in this topic we are going to go through, in this vertical control, we are going to learn the introduction, definition, principles of leveling, sources of errors, and application of leveling. But for today, our lesson objective is to compare different heighting methods. That is our main aim, and I hope you will enjoy. Now, for the overview of what is a leveling, leveling is a process of determining elevations, heights of points of interest above or below a reference datum or differences in elevations. For most practical applications, only the differences in elevation between points of interest and not absolute heights is often required. So, these different methods may be used for estimating heights or height differences, including differential leveling, barometric heighting, trigonometric heighting, gravimetric, and satellite positioning. So, for let's compare what are these heighting methods and know each how it goes about. Differential leveling. So, the basic idea involves obtaining of height differences between points by measuring their vertical distances from a horizontal line of sight. So you can find this is the most common one, and you'll encounter in the field. So again, we have trigonometric heighting. The method is generally used in determination of elevation, differences of lower accuracy, and spirit leveling. It is also useful where it is very difficult or impossible. For differential leveling to be undertaken, e.g. towers, spires, mountain ranges, etc. Then we have barometric heighting. Method consists of reading air pressure differences from which elevation differences are computed. Gravimetry is another heighting method. By measuring the gravitational potential variation between different points, it is possible to correlate this to differences in heights. Then we have satellite positioning, which is a method poised for extensive use in the future, with its only drawback being the determination of the separation between the geoid and the ellipsoidal in areas of interest. So I think in this my presentation you can be able to see the various those methods in graphical form. So we have differential leveling. You can see there you have your damping level there. You see you have a staff at benchmark 100.05 meters. We have a known point elevation. You can see how to get height of collimation, height of instrument minus foresight. So we have also trigonometric heighting, whereby we have two damping level, and you can see one is at high point, the other one is at low point. So this is what you refer to trigonometric heighting. Then we have barometer. You can see the barometer in its image form. We also have gravimeters here. You can see them. They are good. Then we have satellite heighting. There you can be able to see genesis position of point P is given with reference to ellipsoidal. So you can see the images of getting of these heighting methods. Genesis heights have to be converted to arithmetic heights, HP using J adulations. Then we have leveling line and horizontal line. So in this case, you can see there we have direction of gravity, we have horizontal line. So in this relationship, I think as we have seen in the heighting methods, I think you have seen that in these various methods we are dealing with the leveling line and horizontal line. So that's why I decided to bring this topic so that you can understand better the heighting methods or elevations. And here you can see the image of leveling line and horizontal line. The level line at height H means sea level. You can see it there. You can also see the image here with direction of gravity there. Ground surface is here, and then you have horizontal line through C, and you have also level line through A, then level line through B. Now let's define what is a level line. So this level line is a line that is normal to the direction of gravity, and you can see it has been shown by the plug line. And in the plug line, you can see horizontal line and you can see direction of gravity. And a level line is curved by virtue of the shape. So you can see a level line, how it is curved by a level of at a curved shape. Hence, a level is a line in which all points are same height. Then we have horizontal line. Horizontal line is that line that is tangential to the level line at a particular point. Hence, so tangential. So you can see at plug line, we have direction of gravity, then you have horizontal line. So hence our horizontal line is a perpendicular to direction of gravity. So as you can see the direction of gravity, the horizontal line is perpendicular. So as you can see the level line, I will click the slide 9. I will click slide 9. Slide 9. Okay. Now let's look what are datums and what is reduced levels and benchmarks. So in our case, as we have said about heighting methods, we'll be doing trigonometric leveling, we have differential leveling. So as you can see, the datums and reduced level and benchmark. So what is a datum? A datum is a level service which elevation of points may be referenced. The most commonly adopted datum is the mean sea level. And we have reduced level, the elevation or above or below of a point in relation to the datum. So reduced level is very common, and we find it up there. Either then we have benchmark, a permanent monument or feature for which elevation is known. BMs are built on a stable rock, and three types of benchmark can be distinguished. We have fundamental benchmarks, very stable concrete structures, most often built in rock, forming part of primary level of the network. We have ordinary benchmarks, concrete points or marks on rocks, culverts, bridges, etc. constructed between fundamental benchmarks. And then lastly, we have temporary benchmarks, stable points established in course of survey between established benchmarks, which may be the same distance away. So I think it's that for today. If you have a question, you can get me and let me know. Yeah. So in case you have a question, you can let me know. Birech, do you have a question? Birech, I can see your answer. You have a question? Okay, I can see most of you are well. You have understood. Thank you for your concentration.